Hello everyone, and welcome to this quick video on the fabrication workflow of CNC mills. The first thing you need to understand is that our fabrication workflow is broken up into two parts. The first part, which you already know, is CAD, which is computer aided design. Softwares like AutoCAD, Rhino, Vectorworks, 3ds Max, Revit, whatever you're using, this is your CAD software. The next part, and the crucial part for fabrication, is what's called CAM, and that's computer aided manufacturing. CAM is the software that speaks the language of your fabrication tool. So for example, when we're talking to a CNC mill, the CNC doesn't understand your Rhino model. What it understands is how far to move in the X, Y, and Z axis and how fast to do that. And so what we need to do is convert our drawing or model into that language that our machine will understand. Now every CNC machine is different and every fabricator will have a different way they like to operate, so you need to send them an email and ask what they would like. But typically, CNC machines understand what is called G-code. G-code effectively tells the CNC where to be at any given point in time. So we need to move 30 mils to the left in the X-axis, let's do that. We need to move another 50 mils in the Y-axis, let's do that. And we're going to put pressure, slowly bringing the Z-axis down by 3 mils as we go down. And that will give us the shape as we're carving things out. Now, if we were controlling the entire workflow and we were operating the CNC mill ourselves, what we would need to do is actually create that G-code using a software like Fusion 360, where you design the entire process and workflow. You tell the machine what bits it needs to use, you say how big the bits are, how fast the machine is going to be spinning, all of the toolpaths all the way along. Now, at this point though, we're going to be using a fabricator and they're going to be in control of their own machine. So it's best not to create G-code for them, as they will have their own way of working. So for us, what we need to do is think about the file types they will require in order to do so. And at this point, usually you would make a phone call or send an email to figure out what file types your fabricator prefers. But the most common types are usually an OBJ or an object file, or an STL, a stereolithography file, or even a DXF file. We'll have a look at how to create each of these in just a moment. First, let's look at the basics of CNCing. So we've got two different ways of thinking about it. We've got either milling or cutting. So for milling, what we're going to be doing is following along a concentric set of paths, getting closer and closer towards the center. So if you see the little red dot, that dot would follow along the path, and that is the drill bit. And as it follows along the path, we're carving away at the material. And we do this concentrically towards the center, and eventually we're left with that white patch within our material that's going to be carved into that. And of course, we're going to be inside the line when we mill that to make sure that we're not wasting material by having a drill bit following along the center point. In contrast to this, we have cutting outside the line. So we see our red dot again. This time we're going to be following along the edge of where we want our part to be. So because we will be keeping that inside part, we will be following along the outside edge of it so we don't lose any of our material. So it's important to think about, what am I doing when I'm going to be taking my model to the fabricator? Am I going to be milling away some patches, like on the left? Or am I going to be cutting out some objects? And you need to make sure that you understand this so that you can articulate this to your fabricator. Okay, so we know we need to think about milling or cutting, and we know we need an OBJ, an STL, or a DXF file. Let's have a look at how to do this in Rhino. Okay, so we have a geometry here which is pretty conducive to CNCing. When we think about CNCing, we should always think that it's going to start off as some sort of solid piece of material, and then we're going to carve away from that material. So you should always choose surfaces or geometries that pertain to that. Otherwise, maybe laser cutting or 3D printing might be more relevant to you. Alright, so here we've got a bit of a wavy surface that you could imagine if this was one solid block. Then we carve all of this stuff out, we'd be left with this. And we've got some indentations inside there, so maybe this is a bit of a new type of acoustic panel or something like that. What we do need to be cognizant of though, is that when we go to a CNC, we're going to lose some of these sharp corners because of the nature of the process. So a drill bit is a spinning bit with cutting blades on it for a CNC. Now, because that's circular, what's going to happen is when it goes into here, it's going to leave a radius at the corners because it can only really move in the y-axis and then come again in the x-axis. It can't really go back in and get a sharp corner on there because it doesn't have a sharp edge, it has a rounded edge. So we need to be aware of the fact that these squares that we have here are going to have a radius to them. Now we can have smaller drill bits so that the radius gets smaller, but we're never going to get a perfectly square cut edge. So if that is an issue for you, potentially 3D printing again is a different or better option. Alright, so let's have a look at this in terms of what's actually happening. So we start with a solid mass. Let's call this timber, for example. We've got a big mass of pine here, and we want to turn that mass of pine into this surface. In order to do that, we know that the CNC machine needs to carve this effectively out of this in order for us to end up with this product. So we can see that this mass used to be here and that's now gone. We can see that we've got these extrusions coming out, so that would be where the drill bit goes down in to make all of these holes inside there, or the cavities. And then we can see that it's got some bits where it flattens out, where it's got some curvature, and that would be running through the valleys inside here as well. In order to get from here to here, we need to take this away from this object, and we'll be left with this one here. So let's have a quick look at what that looks like. If I delete each one of these layers, this would effectively be the toolpath of the CNC. It takes away 1 to maybe 3 millimeters at a time, depending on the size of the bit. Sometimes we can do more than that with thick bits, but we're going to lose a lot of the fine detail as well. So each one of these deletes that I make is another layer that the CNC would be going through. So you can see that this would be traveling all the way down, slowly carving away and revealing what is left behind inside there in terms of the geometry. And we can keep going all the way down there, and eventually we will have this carved out of our solid object. Another thing to keep in mind when choosing the CNC option is that, of course, by the very nature, we're going to end up with a lot of waste material. So if you think that you can make yours out of a 3D print, or even maybe some laminated laser cutting work, then maybe that's the best option for you. But if you want to have this beautiful curved, carved geometry and you want everything to be nice and smooth, you want to be able to sand it all down, maybe CNC is right for you as well. Alright, so once we've got our file and we're ready to go, we've made sure our geometries are all good, there are a few things we need to do. First thing we need to do is jump over into our properties tab, make sure that one is selected, then click on our surface. Then we're going to come down to details, and you'll remember we had conversations in our earlier videos that we need to make sure this is a closed solid. So in order for the CNC to be able to read it, it needs to be a closed solid. Otherwise, we're going to end up with problems down the line. If it's not closed, a few simple steps. Obviously, we can type in join to make sure everything is all joined together. Another thing we can do if that's not working is go up to Analyze, Edge Tools, and Show Edges. We click on our geometry, and then we can get it to show our naked edges. And you remember that from the previous video. If anything shows up pink, then we know we have a problem, and we can zoom to naked edges, but I don't have any naked edges here because mine is closed and solid, ready to go. This would come out pink for you, and then what you would need to do is make sure that you join them together. You can always do a match surface or a blend surface just to try and make sure everything is closed up, ready to go. And you join all those together and close all of your loops. Another thing that might occur as an issue for you is, let's say your geometry is actually made out of multiple closed surfaces. Now, in order for our CNC to be able to understand that, we of course need to do a boolean first. So what we will do, let's just place our camera so we can see what we're doing first. Place target on here. So we've got these different surfaces inside here, different solids. Each one individually is solid and ready to go, but collectively they're not solid. So what we need to do first is to do a Boolean union. We do all of them together, fully in union. That's going to join everything together for us. And now when we click it, we'll see that this is all one shape. So this would now be ready to be taken over to the CNC as well. So those are the two main things you want to look for. Is my object closed? And do I have multiple objects that I need to union together so that when we check, it says it's going to be a closed solid surface. Once that's all done, what we do is we select our object, we go to File, Export Selected, and then we're going to follow through our normal save process. I always like to do a file save as my Rhino model first, just so that I've got a separate file from my original working file, and that way only the updated geometry has changed in the Rhino file. Then once we've done that, there are a few file types we need to save as. So first one is our OBJ file, so we'll save that as an OBJ. Next one we would do is our STL, or stereolithography, which is that one there. And the final one we would do is a DXF, so which is underneath your AutoCAD drawing exchange.dxf, and you would save all of those. Typically you can save them with the default settings that come through in Rhino, but you may have the fabricator ask you to give some certain settings. So for example, if I go File, Export Selected, and I want to do my DXF, and I do a save as, let's just call this test, it's going to ask for the export scheme, and they might say that actually what we need is a cam setup for our DXF, or we only operate on polylines or lines, whatever it might be. So the default option, they might say to you when you ask them what their file types they like, they might say a specific type as well, and you would just follow through that normal process, and that is your save as. Once you have that, that is all you need to do. You will send off an email to your fabricator with those three files attached: the STL stereolithography OBJ object file and your DXF file as well. Another thing I would do to be super safety sure is to get the final model by itself in Rhino, and then I'm just going to take a couple of views of that. So go up into View, Capture, to File, Transparent Background, and I'm going to take that 1080p. Okay, save those, do a couple of those. Then I would jump into Illustrator, make an A3 page, grab my screenshots that I've taken out of Rhino, chuck those on the page, size them down to whatever you want, and then I just put together some basic instructions for the fabricator and say that this is the final product, this is a few different viewports of the final product, so they know that this is the part we're keeping, and that is all. This really is a step that's not particularly necessary. Most of the time it would be overtly obvious which is the part you're keeping and not keeping. But sometimes that's not abundantly clear, so we might put together a PDF like this one here and say, hey, these are the objects I'm keeping, the rest is waste material. And you also might include information like whether or not we're milling inside the line or we're cutting outside the line. So if we're milling down some shapes, we'd be inside, or if we're cutting out some objects, we'd be outside. So that is the process for the cam end of our workflow, and hopefully you can see here how we would take our drawing or our model from Rhino, get it ready and export it out so that it can be taken through to the CNC machine. Sometimes in fabrication we end up in this situation where we want to cut out our objects, and usually the best thing to do would be to cut them up on a laser cutter ready for assembly, but our material is way too thick and we just can't get through it with a laser. If you're in that situation, you can use a CNC. Now, you might not have the same tolerances and we're going to end up with rounded radiuses, but you can still cut out some shapes with the CNC. So if you're in that boat, you can always watch the laser cutting video to learn how to set up your files and make sure that your drawings are all ordered and ready to go, ready to be cut out. Then all you would need to do is submit the file types of the STL, OBJ and DXF, and you'll still be able to achieve the same process as you would on the laser cutter, but on the CNC instead. Now, if you run into any trouble along your ways, please do feel free to contact me and get in touch, and I'll be happy to help where I can. Your tutors, of course, can also help you out. But another good source of information is your fabricator. The fabricator is going to be the person with the most knowledge in terms of their specific machine and the drawing types and file types that they need. So if you are running into trouble, tell them your situation, what you're trying to achieve, and they'll give you some more information about what to do. Alright, that's all for our workflow on CNC mills. I hope you've enjoyed. Happy carving, everyone.